Working on a text-to-speech model. So I started by asking an LLM, what's a good model for audio generation? It said Katy Perry.
That's funny. That's really funny.
I think you need to give a better prompt.
Oh, honestly, I think you should use a better chain of thought.
Yeah, talking about that, I read research that RLHF is getting worse at hallucinations.
Oh no, that's MCP for sure.
Bro, GitHub has been coolest MCP. No, I think it's Shruti Kapoor.
Are you somebody who's finding it hard to understand these AI terms? Do you sit in a conversation and have no idea what's going on? Then this video is for you.
In order to understand the AI landscape today, I think it is helpful to understand the different layers of ecosystem we have today in the AI landscape. So let's start off with the very bottom layer, which is the hardware. Now at the bottom, we have companies like NVIDIA, AMD, Intel, Huawei, who are actually building the physical processors that power all of this AI computation. Think of them as like the raw brain power cells. These companies manufacture chips, which are actually the resources that AI models run on, train on, and perform computation on. Now, in order to get access to training data, you would need access to these chips. However, these chips are expensive and not everybody can afford them. So there are companies on top of this hardware layer, which is the cloud providers, such as AWS, Google, Alibaba, Microsoft Azure, that rent out these chips and provide computational resources to people and other companies so that they can use these cloud providers in order to train their data. You can think of these as the factory in an industry where you get access to the resources and you can produce items in the factory. Now, what are these items? These items are the models. Companies that are making these models are companies like OpenAI, Anthropic, Hugging Face, Meta, Google. So then there are these companies who use this computational power provided by these cloud providers in order to build the models. Models is the brain of our AI systems. So companies like OpenAI, Google, Meta, Hugging Face, Anthropic, they build these models that can then be used by applications such as ChatGPT, Claude, Midjourney, Canva AI, and so on. So these applications are the tools that people actually interact with. Now, if you're a developer, you would likely be working on the foundational models layer. And if you're a user, you will likely be working on the applications layer. So I hope that gives you a clear picture of the AI landscape. To summarize, the hardware chips made by companies like Intel, NVIDIA are rented by cloud providers like Google, Amazon, that are then used by companies like OpenAI to build models, which are the brain of the system, which is then used by applications like ChatGPT, Claude, Anthropic to build the tools that we use today. First up, let's talk about what is AI. AI, or artificial intelligence, is a field of computer science that is focused on making systems that can perform as well as human intelligence. In fact, the whole point of artificial intelligence is to create systems that can think as well as humans do and perform tasks such as recognizing patterns, make prediction, understand language, as well as humans do. The concept of artificial intelligence has received a lot of popularity in the last 5 years, but it is not a new concept. In fact, the first time artificial intelligence was coined was in 1956. In 1950, Alan Turing's paper, Computing Machinery and Intelligence, is considered as the first paper on AI. This paper was the first to introduce the concept of imitation game, which is now known as Turing test, which is used to determine if a system or a computer is as good as human intelligence. Now, machine learning is a type of AI that allows machines to learn from data. You train the machine to learn from patterns, and then based on the patterns, it predicts what is going to be the next output. For example, if you provide an input like 2, 4, 6, 8, 10, it understands that the next output should be 12. So instead of writing the rules to instruct the computer what to do, we train the computer to learn pattern in the data and figure out by itself what the output should be. Let's consider this example. We're feeding this data of size and price for houses in our area. For 1,000 square feet, the price is $150,000. For 1,500, it's $200,000. And for 2,000, it's $250,000. Now, the model will look at this pattern and analyze that for every 500 square feet increase, the price should increase by $50,000. So now if you ask the model to give a price estimate of a property that has 1,800 square feet, it understands by looking at the pattern and gives a prediction of a price of $230,000. That is machine learning. Some examples of machine learning that you may have seen in your day-to-day life is Netflix recommending you movies, or you marking certain items as spam and not spam, and then your email client becomes better at understanding which emails are spam. Neural networks. Neural networks is a popular ML approach that mimics the way brain cells work. Imagine neural network to be a bunch of layers with tiny yes or no decision makers called neurons that work together to give a certain output. Let's look at this image. Let's say we want to understand if an image is a cat or a dog. The input layer is where we feed in the initial image, which is the pixels data of the image. The hidden layer is where the processing happens. This layer determines what the pattern looks like and how close it is to a cat or a dog. It could be recognizing patterns such as hair, fur, number of legs, facial features, whiskers, things like that. The hidden layer actually processes this information and sends the final prediction over to the output layer, which then converts this pattern recognition into a prediction. So it can say something like 85% cat, 15% dog. The more hidden layers we have, the deeper the neural network is, which is what makes deep learning. So deep learning is a type of machine learning that uses many layers of neural networks. Examples of deep learning systems are modern speech recognition systems, image recognition systems, natural language processing systems. We've been talking about training the model for a long time, but we haven't really talked about different approaches of training the model. So here are common approaches you may have heard of. So we talked about AI. Let's talk about the different terms of AI that are popular today. The number one term that you should know is model. Model is the brain, is the core central unit that predicts data. For example, GPT-4 is a model that is trained on a large amount of text-based data. Foundational models are models that are trained on trillions of words, books, text, and they can be adapted to many tasks. So it's this adaptation to many tasks that makes them a superpower, because many applications can be built on top of foundational models by either using the foundational model as is or by fine-tuning them. For example, generate code to answer customer service questions or to answer medical questions. They are called foundational because you can build other models on top of them. Some examples of foundational models are GPT-4 from OpenAI or Claude from Anthropic. Talking about GPT-4, let's also talk about LLM. LLM, or large language model, is a model that is trained on large amount of text-based data. These kind of models are really good in understanding text-based data. For example, predicting the next word, generating a script, creating a blog post, or even summarizing large amount of text. So in order to understand the difference between model, foundational model, and LLM, think about this. Model is kind of like a trained dog. They can perform certain tasks. A foundational model is like a guide dog who has been trained on lots of tricks. And LLM is kind of like a dog who has been trained in multiple languages and can respond to commands in multiple different human languages. An example of LLM is ChatGPT. GPT stands for Generative Pre-trained Transformer. So let's talk about what that means. The G in GPT stands for generative. So what does generative mean? Generative means that the model can actually take an input and create something completely new from it. For example, I've given a prompt to my AI model that says, generate an example of a woman eating a cake, riding a camel on a mountain top. And this is the image that it generated. Now, this kind of image has never existed before. I just generated it out of the imagination of my mind. So these kind of AI systems are not just good at analyzing the data, but they can also create new content from that data. And they can be really helpful in idea generation, in creating new code, in creating new text, in creating new media. This is what forms the basis of ChatGPT. Now, the P in ChatGPT stands for pre-trained, which means that the model has been pre-trained on a large amount of data. But the T in ChatGPT stands for transformer. Let's talk about transformers. Transformers is the architecture behind modern language models. What's cool about transformers is that it allows the model to have context of not just the current word that it's looking at, but also the words surrounding it in the entire sentence. So it uses attention to understand the context of the sentence. So here's an example. Imagine if I give it a sentence, the trophy didn't fit in the suitcase because it was too big. What does the word it refer to here? The transformer is able to understand that it likely refers to the trophy as opposed to the suitcase because it has context about the words surrounding it. The architecture of transformers was actually first introduced in the paper Attention is All You Need in 2017. And it is this engine that ChatGPT uses to understand the context of sentences, which makes it super fast. So now let's talk about what is ChatGPT, everybody's favorite tool. And the cool part about ChatGPT is built on top of a foundational model like GPT-4o that can be used to do multiple different tasks and can be adapted to various different applications. What's made it really popular is that you can use natural language, which is English language, to talk to ChatGPT in something that's called as prompts. So let's talk about prompts. Prompts is actually just the text or the input that you send over to an LLM. Now, the quality of your prompt determines the quality of your output, which is why prompt engineering is the craft of writing beautiful prompts. Now, what makes a good prompt is the amount of information or context you can provide to LLM in the prompt. So let's say that you're trying to generate product description for a coffee maker. A basic prompt could be write me a product description for a coffee maker. But a better prompt would follow the CRISPR method. C standing for context, R standing for role, I standing for intent, S standing for specificity, P standing for parameters, and R standing for refinement. Now let's transform that basic prompt into a CRISPR prompt. For example, if you're trying to understand promises in JavaScript, a basic prompt would be explain JavaScript promises. But a better prompt would be explain JavaScript promises to me as a junior dev. Show code examples, give me relatable examples, and help me build an app with it. This gives you a much more structured approach to the output that you get back. And the craft of doing this is called prompt engineering. Then we have different types of prompts called zero-shot prompt, few shots prompt, and chain of thought prompts. Let's talk about them. Zero-shot prompt is when you ask a question without giving any examples. So for example, you could say something like, is 19 a prime number? Zero shot, zero examples given, straight to the point, just ask questions. Then we have few shot prompt in which the examples that you give help the model understand the context of your question. So you could say something like, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, is 19 a prime number? So you're giving it a few examples to understand which of the numbers are a prime number. And then in chain of thought, you ask, is 19 a prime number? Let's think about why. So the model would think something like any number that is divisible by itself and 1 only is a prime number. Therefore, 19 is a prime number. And that is chain of thought reasoning. Now you could give a large amount of text as prompts or you could give a short amount of text as prompts. What is the difference? The difference is the amount of tokens that that prompt translates to for the model. The more number of tokens you have, the more price you have to pay. For example, a sentence like a cat and a dog could be 4 tokens, which means you'd be paying according to that. But if you were to write a huge sentence, you might have noticed in ChatGPT that sometimes it says you have run out of memory. That is because a large prompt can lead to a large amount of tokens and therefore causes more money and resources. Really, token is a chunk of text or words that the AI model uses to process the information. And finally, hallucination. Hallucinations are really funny because the model can very confidently generate answers for you that may be completely untrue. Let's try this out. I want you to ask your favorite LLM, what does MCP? And let me know what it says. The correct answer for that is Model Context Protocol. But I've seen models like ChatGPT give wrong answers for that. So try that out and let me know in the comments what is the full form of MCP as given by your model. Now, why hallucinations are important is because you need to be careful of the information that the LLM is giving back to you, because it can sometimes hallucinate or just lie about the data. Number 1, supervised learning, in which you give it large amount of data with the right answers so that it learns from those answers and predicts what the next output should be for a question. So for example, you can give it large amount of pictures labeled cat and dog, and next time when it sees an image, it can try to understand if it's a cat or a dog. So it is supervised learning by giving it the right answers to help it predict the next prompt. Secondly, there is unsupervised learning, in which you give it large amounts of data and the model needs to figure out by looking at the data what is the pattern. For example, you can give it large amounts of customer data to help understand patterns in data, such as most commonly asked questions, most common pain points, and this way there is no right or wrong answer, but the model has to figure out patterns on its own. So behind the scenes, the model needs to understand the clusters without any predefined labels. Thirdly, we have reinforcement learning from human feedback, which is one of the most important form of training that even ChatGPT uses. In this, the model performs a task and the human then gives feedback in terms of good or bad to help the model become better. An example is when you write a prompt in ChatGPT, it gives you a response back and you can give it a thumbs up or thumbs down. That helps the model to understand the quality of its response. And finally, we have fine-tuning. Fine-tuning helps in giving specific data set to the model so that it becomes more specialized to a specific category. For example, you can give a foundational model such as GPT-4o highly specific data about medical instruments so that it becomes much more trained in debugging when a medical device breaks. This way we can create highly specialized models from foundational models instead of having to retrain the model completely. Now, let's talk about the 3 most important tools that are available today in the AI world. Number 1, RAG, Retrieval-Augmented Generation. This is really cool because with the help of this, you can give additional context to LLM, which means you can give additional information to LLM to help it answer questions better. Now, this is kind of confusing because how is it different from fine-tuning? The difference is that with RAG, you give it additional context so that when you ask it a prompt, it has a specific source that it can talk to in order to gain specific information. For example, if you're working at a company and you have access to databases of that company, you can give your LLM model access to that database so that if you ask a question about a specific customer, it can look up in that database to find answer. Now, it's not trained on that data, as in you're not providing that information for it to train on it. However, it's just for additional context and an additional source that it can look into to find answers. So first it retrieves and then generates the output, Retrieval-Augmented Generation. Another tool that has become really popular today is AI agents. I actually did a whole video on AI agents, what they are, the 101 of them, and how to build an AI agent, which I will link here. But the main idea about AI agent is that these are autonomous or close to autonomous systems that can access multiple resources, multiple different tools in order to perform a task. An example of an AI agent that can do this for you is a code editing software that can look at your PR, give you feedback, and then create a new PR with the revised feedback. Another example is a booking system that you can give a prompt to, such as I want to travel to Italy and book me a 10-day trip. It can give you a recommendation of the different places to go and then finally book those for you. Now, how agentic it is or how autonomous it is different today than what it may be in a few months. However, right now, these systems are not completely autonomous. The degree of how autonomous they are define how agentic they are. So today, a system may be able to find 10 days in your itinerary, give you a list of recommendations, and give you a list of hotels to stay at, and give you even a link of resources to go book them, but may not be able to book it for you, which is actually a good thing. And finally, MCP, Model Context Protocol. What is MCP? Let's actually talk about MCP in simple terms. Imagine that you have a computer at your home that has access to internet, like every computer. However, you have smart devices at home like a smart fridge, smart washing machine, your iPad. You want to create a system that can actually control all of these smart devices through your computer itself. Now, because all of these devices are from different companies, they have different interfaces or different APIs to talk to. So now you have to create a system that can talk to all of these different APIs, and they're all over the place. They're all different types of structures. They have all different types of APIs. MCP is a standardized way of talking to these different systems. So now instead of having to create a different API for each of these smart devices, you can use a now standardized way of talking to these different devices, which makes it super cool for AI systems, because now instead of having to write a separate integration for a different system and different tool, we can use a standardized protocol for talking to these different companies or these different systems. What has made MCP really popular is because it is now providing a standard way to interface with the different AI systems in the market. So as a provider who needs to provide their tools to the AI ecosystem, you can create an MCP server, and a client can then simply call your MCP server in their application in order to get access to your tools and data, which makes it a lot easier to integrate with a new AI data source. So I hope this video was helpful for you. If it was, give this video a big like and subscribe. Now, if you want to build an AI system, click this video. And if you want a list of prompt templates that I use to do my research on ChatGPT, Gemini, and Claude, find it in the description. Thank you so much for watching. I'll see you in the next one.
Sit. Pepper.
Look at me. Pepper. Hello. Pepper.
Pepper.
Please shot ले ले मेरी माँ. Please shot ले ले. Please ले ले.
Oh.
चलो छुट्टी.